All right, so last section we're going to look at on solving triangles is 8.2, and that's on law of cosines. Now, using law of sines, we already solved these three types of problems. Side angle angle, angle side angle, side side angle. Does anybody remember the other two types I said we were going to be able to do with this law? Yep. Side, side, side. That's one of them. And there's one other one. Yep.
Side angle side.
Side angle side. Yep. So that was law of sines. This is law of cosines. This is what a side angle side triangle looks like. You've got two sides, and this time the angle that you know is between them. The reason you can't use law of sines on this is because if you set up a table for this, you would have a side, and then an angle. You wouldn't have three pieces, you wouldn't have two pieces of information in the same row. And the same problem happens with side, side, side. You'd have the side, and the side, but no angles. If you don't have a full row, the law of sines doesn't work. Right, so we're going to look at the law of cosines. Now, you can really take any triangle and turn it into what kind of triangle? And we did this in the canyon problem, and we did it in the tornado problem. You can take a triangle and turn it into, yeah, you can always turn it into a right angle if you draw, if you draw the height in the right spot. You can make it a two right triangles. And that's where the law of cosines comes in. So what I'm going to do is just move this temporarily. Okay, so all I've done is draw the standard triangle we usually do. I've labeled the three sides A, B, and C. A across from alpha, B from beta, and C across from gamma. And then I split it into two right triangles, okay, by drawing in the height from beta perpendicular to the base. Okay, I called that height Y. I don't want to call it H because we could confuse it with hypotenuse. I know we've used H, but let's call the height Y. And we're going to call this part from here to here X. Now, to figure out what the law of cosines is, it can only use letters that are in the original triangle. So the things in the original triangle were A, B, C, alpha, beta, gamma. Those are the only 6 things that can be in the formula. This X and Y can't really be in there because that would never be information I would give you in a problem. I would only give you the 6 things that are circled. Three out of 6. Okay, what I want to do is take this triangle and set up the Pythagorean theorem for it. Okay, using the 3 sides. Well, what's the height of the green triangle? Yeah.
Y.
Okay, so we got the height. So, we're going to have like a y squared in there. What's the hypotenuse?
C.
C, so that's fine. But I need this. How would you represent that length using what I've labeled in that picture? Yep.
X. Or is it 1/2 B?
Well, X is from here to here.
They wouldn't be the same on both sides.
No, not unless we knew that the was an isosceles triangle. But I tried to draw it so it doesn't come down right in the middle. It's a little bit further, I think, on one side.
Okay.
So I could have probably maybe drawn it, would have looked even better like that. But yeah, we don't know that this piece and this piece are the same. But it is going to be something with the X. Yeah?
B minus X?
Yep. So we're going to call this part B minus X. All right, now, can somebody set up my Pythagorean theorem using this, and that for the green triangle? Yeah.
b minus x squared plus y squared equals c squared.
B minus x squared plus, what did you say, y squared?
Yep, equals c squared.
Okay. Now, we can't leave the x and the y in there. This has to go. And this has to go. Because they're not part of the original triangle. They're like extra things you labeled that you would never really know. So what I want to do is figure out something I can plug in for x. Let's start with that. All right, so x. Let me try and move away some of these circles. All right, so let's focus on x first. I'm going to try to figure out a formula that involves x and involves a and that angle which they would give you in the problem. What position is side x relative to gamma? Yep.
Adjacent.
Adjacent. What position is the side I've labeled a? Hypotenuse. What trig function has adjacent and hypotenuse in it?
Cosine.
Cosine. Okay, so let's make a formula for x. Cosine of gamma equals adjacent over hypotenuse. Now I want to solve it for x, so I have something I can plug in. What would x equal when you rewrite it in terms of the original things they would have given you?
A cosine gamma.
A cosine gamma. So that is going to get plugged in right there. And now we got to do something similar for y. Okay. What trig function could I use that would involve y, a, and gamma? Those three things. Yeah.
Sine.
Yeah. So sine of gamma. And what would sine of gamma equal next?
Y over a.
Yeah, opposite over hypotenuse. So y over a. Do the same thing. Let's get y by itself. And what would the formula for y be?
A sine gamma equals y.
A sine gamma. Okay. And that's a gamma. That's going to get plugged in right there. When you plug those two things in and simplify it, that's the law of cosines. Right, so it all comes from breaking it down into two right triangles and using the Pythagorean theorem. That's the whole law of cosines is based on Pythagorean theorem. Right, let's make the substitution. So we have b minus a sine gamma. Or no, b minus a cosine gamma. Sorry. Okay, we need to square that. Plus, instead of y, we're going to put a sine gamma. Square that. And that's equal to c squared. Okay, when you have to FOIL out something like this, that's a binomial. Does anybody remember there's it's like a word some people use to try to remember how to do it? What is it? Yeah, that's a FOIL. That's like foiling. It's like x minus y squared. That's exactly what we have right here. So think of it, if it helps to write it so you can see it, you've got that times this. I'm not going to write the whole thing, but that's what you're doing in that first part. So b times b is going to give me
B squared.
b squared. And then you're going to have b times negative a cosine gamma, and another b times negative a cosine gamma. So how many of the negative, we'll call them negative ab cosine gammas do we have? Yep, two. When you're trying to square a binomial, it's always twice the product of the two things inside the binomial multiplied together. I just, instead of saying BA, I'm saying AB. Just put it in alphabetical order. All right, so we got AB cosine gamma, another AB cosine gamma. And what about negative A cosine gamma times negative A cosine gamma? What's that going to be? Yep.
A cosine gamma squared.
So yeah, plus, what is it?
A cosine gamma squared.
Well, remember, you've got two factors here. So you're really multiplying A times cosine times A times cosine.
Plus B squared plus cosine gamma squared.
So that's what you get when you do the first part. Now the second part, when you have to square a product, you just square each factor. A squared sine squared. That's a lot easier. So A squared sine squared. That's not FOIL. It doesn't have a plus or minus in it. So A squared sine squared. And it's just going to stay equal to C squared till we're done. C squared never changes. Now, let's underline the terms you got. First term, second term, third term, fourth term. 4 terms there. Terms are separated by plus and minus signs. If you look at 2 of the terms, they have something in common that if you factor it out, what's left turns into a trig identity. Does anybody see, again, let's just call these terms 1, 2, 3, 4. Which 2 terms could you factor something out of, and you're going to be left with a trig identity? Yeah?
3 and 4.
Yes. What could you factor out of terms 3 and 4?
A squared.
A squared. Yep. So let's factor it out. And what are you left with if you factor a squared out of that whole thing? What would be left inside the parentheses? Yeah.
Cosine squared plus sine squared.
Cosine squared gamma. Sine squared gamma equals c squared. And that's a Pythagorean identity. What does all that turn into that I just underlined? Yeah,
Is it 1?
that all turns into 1. So this is all gone. And it becomes a 1. Well, what's 1 times a squared?
B squared.
Just a squared. So what I'm going to do is I'm just going to rewrite this and put it in the order that you would normally see it. So you have c squared on one side, a squared plus b squared minus 2ab cosine gamma. That's the law of cosines. I mean, you could write it in that order if you want. That's fine. I usually just put the a squared in front. So a squared b plus b squared minus 2ab cosine gamma. So what's important to remember about the law is not really this exact formula with those letters. It's more important to remember kind of the pattern of the letters. So the first part, it's like Pythagorean theorem. C squared equals a squared plus b squared. Whatever letter you put here you put the other two letters here. Okay. So in a minute, we're going to write the same formula, but instead of starting with c squared, we're going to start with b squared. So c squared, a squared plus b squared, minus twice the product of the two letters you just wrote down right before it. And then the last part is always the cosine of the angle across from the letter you started with. Okay, that's the pattern. So following that same pattern, if I start with b squared, what do you think I would have in these two spots? Yeah, yeah, a squared plus c squared. And then what would come after it? Minus what?
Minus 2ac.
2 times the letters you just put right before it. And then cosine of what angle?
Beta.
Beta. Okay. Perfect. Right, and what if you started with a squared? What do you think I'd have right after that? Yeah.
B squared plus C squared.
B squared plus c squared, yep.
Minus 2 times C.
2 times bc, yep.
Cosine alpha.
Cosine of alpha. Yep, exactly. Because you can write the law of cosines with any letters you want. If you want to use ijk, you could do I squared equals j squared plus k squared minus 2 times j times k. It's not what you call the letters, it's the pattern. But A, B, and C are pretty common. That's it. That's the law of cosines. So there's two different kinds of triangles we can use it on. There's this type. This is a side angle side triangle. In side angle side, you got to do one of each. One time you need to solve for a side. The other time you need to solve for an angle. When you do side, 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 you don't have to ever solve for a side. So this kind of problem doesn't really cover it as much. There's less going on. Okay? This one covers a little of everything. How to do sides, how to do angles. When you are doing law of cosines, if you are missing a side, that is what you have to find first. So that's kind of the rule with law of cosines. If you're missing a side, find that side first. The reason you need to find it first is because every version of the law of cosines has every side in it. They all have A, B's, and C's. So if you're missing a side, and you want to use one of these formulas, you can't be missing anything else. Right? So which version of the law of cosines do you think we're going to plug into to find C? Version 1, 2, or 3? Yeah, you have to use 1 because you know A and B, and you know gamma. See, that's the one you got to use. Yep. Okay, so let's write it down. I am going to fill in. I am going to simplify some things as I go. Okay, what is A squared? 16. So let's just do that. Okay, what's B squared? 49. Now let's do 2 times A times B all at once. What's 2 times 4? 8 times 7. So 56. Cosine, and we know gamma, 42. There's really only one more step that we're going to do by hand. What can I do on the right-hand side? Just to simplify what I have a little bit. We can do 16 plus 49. Yep. And what does that give me?
65.
65. That's really the last thing that you can do. Otherwise, you're going to start rounding. There's nothing else you can do. You can't do 65 minus 56. PEMDAS. You'd have to do multiplication first. So the only thing we're going to do now is get C by itself. What do we have to do on both sides? Take the square root. Now just type that in. So 65 minus 56 cosine 42, and that's all under a square root. So 65. Okay. And as long as I typed everything in right, and okay, no, that's not right. What's wrong with that? Yeah, I'm in radians. Okay, so that's wrong. So if you got 9.348, you were in radians. You should have gotten 4.836. Big difference. 4.836. Now you are going to have to use C to find alpha and beta. So if you got C wrong, then alpha and beta are going to be wrong. Right? Any question on that? Okay, so that was all to find C. Now, once you know all the sides, you can find any angle you want. We need to do one of them, and then we'll add and subtract from 180. Do you want to do alpha or beta? Alpha. Okay, so let's do alpha. So the law of cosines that has alpha in it starts with A. A squared equals B squared plus C squared minus 2BC cosine alpha. All right, so now let's fill it in. So A squared is 16. B squared is 49. Okay, I'm going to need help here in a second. What is this? I need to know that number now. 65 minus 56 cosine 42. What is it?
Never mind, I said the wrong thing.
Oh, no. Anybody have what that comes out to?
23. Can I just square what we have?
You can. It won't be as accurate because what we had there was rounded. This would be as accurate as we could be.
I have it in the calculator.
Oh, you got, yeah, that'll be okay then.
23.384.
Okay, so 23.384. Right now I need a little help on this part. 2 times B times C. Well, 2 times B, that's 2 times 7, that's 14. I need 14 times 4.836. 61.404. Cosine alpha. All right, we can combine like terms. These are your only like terms. We're okay?
Yeah, I got 67. I did too.
All right, that's a big difference.
Yeah.
So what?
I don't know.
So 14 times 4.836.
Oh, I did 3
Yeah.
and 6.
So what are we supposed to get here?
67.7.
Okay. Yeah, that's pretty big. 67,704.
Yeah.
Okay. All right. Now we're at this step. We can combine these together. What's 49 plus 23? So 72. 384. Minus 67. Cosine alpha. Now, solving this equation is exactly like solving this. The steps here are exactly the same steps there. What would be your next step here if you're trying to get this x by itself? Yeah?
Subtract each side by 72.
Right. You can't do 72 minus 67 because the 67 is multiplied by a variable you don't know. So you got to bring 72 to the other side. So that's gone. Okay, I'm going to need 16 minus 72.384.
56.384.
56,384.
Yeah, negative.
Negative, yeah. And that's equal to negative 67,704. All right, now we have 2 steps left to get alpha alone. What would be your next step? Yep.
Divide both sides by negative 67.74.
Yep. So let's divide both sides by negative 67,704. And let's get rid of cosine at the same time. How do you get rid of cosine? Yep. Inverse cosine. So negative divided by negative, that's going to cancel. And it's going to be the inverse cosine of 56.384 divided by 67.704. Yeah, I'm not even going to figure out what 56 divided by 67 is. Because if I do this out and then I round it, I've already rounded the top and rounded the bottom. I'm going to divide it and round it again and then type it into inverse cosine and round it again. But that's a lot of rounding. So try to limit the rounding as much as you can. Okay, so 33.612. If we're going to 3 decimal places, then everybody should be at least around like 33.61. If you got like 614 or something, I mean, that's okay. But if you're getting like 33.91, no, that's not good. That's too far off. Okay, so 33.612. Right, now we're just going to add them all up and subtract from 180. So 180 minus 33,612 minus 42. So that makes beta about 104.388. And that's a law of cosines problem. So the top part was finding a side, and the bottom part was finding an angle. Those are the only 2 types of things you ever have to do in this problem. Any questions on that? All right, so that was side angle side. This is side, side, side. When you have all 3 sides, you can pretty much find any angle you want first. Okay. But you have to do law of cosines for at least 2 of them. And then you can subtract from 180 to get the 3rd one.
I had a question about the last one. Could we have used law of sines instead to find alpha?
So what ends up happening if you start the problem with law of cosines and try to finish with law of sines. So this was A, this was B, that was C, and that's gamma. So does everybody see how we started with side angle side? That's law of cosines. Once you figure out C, that was 4.836. Now you know a side, a side, and a side. So you know all 3 sides. You also know a side, and an angle. These 2 would be law of cosines, if you think about the problem finishing it that way. This would be law of sines. But what can happen with side-side angle? We talked about it yesterday.
Have more than one solution.
Right. If you try to finish this problem thinking of it this way, now you're going to get into a whole 2 solution, 1 solution thing. So we just kind of want to avoid that. So that's why we finished it with law of cosines. Because you're guaranteed this only has 1 solution. But if you use side-side angle, you may have to subtract your angle from 180 to figure out, is it the reference angle, or is the answer 180 minus the reference angle? Which answer should it be? It'll only be one of them. But this avoids all that. But yeah, it's a good point.
Mr. Hager, on the test, will there be like a room for error with the rounding?
Well, I'm going to have you go to 3 decimal places. So, I mean, if you get like 104.39 or 104.37, something like that, that would be okay. But if you're getting like 104.56, that something's pretty far off. As long as you're going to 3 decimal places, you should at least be accurate to 2. Okay. All right, so let's try this one. Any angle we want to find first. So which angle do we want to do first?
Gamma.
Gamma. All right. So gamma, that's the one that starts with what letter? C. Now, there is something I should mention. It is possible for side to have a no solution. Not 2 solution, but it is no solution. And it's very easy to figure out. If you look at your sides, any 2 sides added together need to be bigger than the third. Because if I gave you sides of like 2,000, 1, and 1, those aren't going to connect to make a triangle. It's impossible. These will work. 9 plus 7 is bigger than 5. 7 plus 5 is bigger than 9. And 9 plus 5 is bigger than 7. So that's fine. Any 2 sides added together have to be bigger than the third. If they're not, you can write no solution. Even if they're equal to the third, like if I give you sides of 3, 3, and 6, you can't make a triangle with them. It doesn't work. 3, 3, 6. Has to add up to be bigger. Okay, so the nice thing is usually when they give you the sides, there's no decimals. Usually. Okay. So what's c squared? 25. A squared? 81. B squared? 49. 2ab. Let's do 2 times... I don't know if I can do all that. What's 2 times 9 is 18. What's 18 times 7? 126. And then cosine gamma. Okay, combine like terms. What's 81 and 49? 130. All right. What has to go to the other side now? The 130. What's 25 minus 130? Negative 105. And now let's do the last 2 steps together. What would be your fraction on this side? Yeah?
Negative 105 divided by negative 126.
So negative divided by a negative, that'll give me a positive.
Yeah.
And now what do I have to do to that fraction to get rid of cosine?
Inverse cosine.
Yep. There you go. So that's going to be your answer for gamma. Inverse cosine of 105 divided by 126. 33.557. And then you really do the exact same thing again for alpha or beta. It's just all the numbers are going to move around to different spots. Is there any question how you would do the alpha or beta? You could do it in exactly those same amount of steps. So that's how you solve a side-side-side problem. All right, let's look at this one. So this one says that we have a surveyor that wants to find the distance between 2 points on opposite sides of a building. So So they're gonna give us a diagram here to help us. Basically, you're gonna have a building, and then you're gonna have 2 points on each side of it. You could think of the building as it could be a river, so maybe it would be hard to measure across it for whatever reason. But you've got something in the middle that's blocking you from directly measuring straight across. So let's see what that's going to look like. So we've got our object in the middle. And, if you don't want to think of it as a house that's in the way, you could think of it as 5 lions. Okay, we have 5 lions in the way. So we can't measure straight across because they get upset when we try to walk by and they get angry. So we got to measure between A and B. And then the surveyor is going to be standing at point C. Okay, that's going to be a point that's, where they can see both points that they're trying to measure between, but out in front of it, at a safe distance from the 5 lines. Okay, and if we want to have a surveyor, let's see, we have a picture of a surveyor. This guy he could be a surveyor. Or not, he doesn't have to be. But I kind of wanted him to be. He's thinking, he's not going to do it. Okay. So, we could have an elf. No, nobody wants to be a surveyor. Okay. So, well, anyway. Oh, he does. Okay, great. Thank you for participating. Okay, so we got our surveyor right there. And the goal is to figure out the distance between points A and B in that triangle. And they've given you exactly the information you need for a side angle side triangle. We need a name for this top side. Let's call it
C.
Yeah, you could. Well, we've used C for that angle down there.
Lowercase c.
So we could use a lowercase c. Just to avoid any confusion, I probably wouldn't pick a C, since we already have a C. You could pick, if you want to use C, you could. Okay, but that's X. Okay, so how's my formula going to start out to solve for X using law of cosines? Yep.
X equals.
X squared equals. Yep.
110 squared.
110 squared.
Plus 160 squared.
Plus 160 squared. Yep.
Plus, minus 2 times 110 times 160.
Yep.
Cosine.
Perfect. That's exactly how you solve it. Any questions on the setup? Now it's just a matter of typing that all in and seeing what you get. So we could do that all at once. Just what do you have to do to get x by itself? So it's going to be the square root of everything we just wrote down. 110 squared plus 160 squared. Okay, calculator will handle order of operations okay there. Minus 2 times 110 times 160 times cosine 54. I think it'll handle all that fine. So the distance between the 2 points is 130.422. 130.422. And did they give us a unit of measurement in the problem? Feet. Okay. There you go. 130.422 feet. So that's how you can safely measure the distance between 2 points if 5 lions are in the way and you have an elf to help you. Safety first. Okay, so that's it. So side angle side. All right. So now two applications of law of cosines. Well, one of them really is an application. How do you find the area of a triangle? There's a formula, yeah. It's 1/2 the base times the height. And that's great as long as you know the base and you know the height. But what if, just go back to this triangle. What if I gave you that triangle and I said find the area of it? Well, you don't know the height. You could find the height if you thought about drawing in an altitude, and then you could somehow work backwards and figure out what you need. Okay, but you could figure it out. Or you could even draw the height over here. Make a triangle that way, and you know this side. Well, you know that side. You could figure out that angle if you figured out that angle from law of cosine. So you could figure it out, but we'd rather have an easier way. So let's look at this, and let's find a formula for h. Okay, h is the height. What do we want to use to do it? Let's use this side. Focus on that triangle. I want to use this angle, this side, and I want to find that side. What position is h relative to gamma?
They both tripped. Yes.
I'll write them up. What position is h relative to gamma? Yes.
Adjacent.
Opposite.
Opposite.
Opposite. Yeah. H is opposite. And what position is a? Yeah. Hypotenuse. What trig function has opposite and hypotenuse? Yeah. That's adjacent and hypotenuse. Sine. So what we're going to do now is the same thing we did when we proved law of cosines. We're going to come up with something we're going to substitute in for the height. Okay. What's my angle? Gamma. And what side is opposite? H. And how about the hypotenuse? That's A. So what do you get when you get H by itself? Yeah.
A times sine of gamma.
Perfect. A times sine of gamma. That's the height. So now fill that in for the height. And you have another formula for the area of a triangle. Okay, that uses trig. So you'd have 1/2 the base. Hopefully they give that to you because you have to know something. So the base would be b, and the height is a sine gamma. I usually put that in alphabetical order. 1/2 AB sine gamma. And there's 3 different ways you can write it. I showed you guys this last week. Okay, like the law of cosines, it's not important to remember the exact letters. It's the pattern. Okay? It's always going to be 1/2 times the product of 2 sides, any 2 sides you want, but then it has to be the sine of the angle between the 2 sides. So if you look at a diagram that's properly labeled, alpha is always the angle between sides B and C. Here's B, here's C, alpha is always right between them. Okay. If you used A and B, the angle between A and B is gamma. And that's why it's gamma. Okay, so that's another formula for the area of a triangle. 1/2 the product of the two sides times the sine of the angle between them. Okay, so this formula really builds in finding the height for you when you don't know it. It's just part of the formula. It figures it out. Any questions on those three formulas? Let's try. Now, you don't know which version of the formula you're really using because the sides aren't labeled A, B, and C. It doesn't matter. They don't have to be labeled. Okay, you're just going to find the area of that triangle using the concept right there. So, anybody tell me what the calculation would be for the area of the triangle? So 1/2 product of two of the sides times the sine of the angle between them. Yep, exactly. So this part right here, 3 sine 105, that's the height of the triangle. That's the base. That's the 1/2. And 3 sine 105 is the height. If you drew a right triangle and tried to figure it all out. Okay. What's 1/2 of 3 times 12? 18. And then we have to do sine 105. 18 sine 105. Okay, 17.387. Now, what did I just find? That's the what? Area. So what do you always make sure when you write an area? Right. We don't have an exact unit, so we'll just say square units. So that's how you can find the area of a side angle side triangle. Questions on that? Now, don't write it yet. Just look at it. Is that a side angle side triangle?
No.
No, it's a side, side, side. Okay, so not to scale. Let's say this is 9, 7, 5. How could you, or what would you have to know here to apply the formula I just showed you? You'd have to know one angle. Which angle? Which one? Yeah, any. If you could figure out any of these, you could use the formula. How could you find one of those angles? Yeah. Well, we've got a way to figure it out using something we proved earlier. You can always break it into right triangles and try to do it that way. But we've got an easier way that's kind of less thinking. Yeah?
Use the law of cosines.
Yeah. You have 3 sides, 9, 5, and 7. You could just use the law of cosines, which we've already done, find one of the angles, and plug it into the formula. Now, using law of cosines, though, that's an extra 5, 6 steps. So there is a way to find the area of a side, side, side triangle without doing the law of cosines. This formula, it's called Heron's formula. The proof of it uses the law of cosines. So law of cosines is built into the formula. And that's the formula to find the area of a side, side, side triangle if you don't want to use law of cosines to figure out an angle. So that says the square root of s times s minus a, s minus b, s minus c. Now, what's in that formula that we're not used to seeing? Yeah? Yeah, we haven't talked about what s is. Well, if you add together a, b, and c, what do you call that in a triangle? It's the perimeter. And if you take half of the perimeter, does anybody know what you call half the perimeter?
Section.
So that's a good guess. It's like it is a section of the perimeter, but there's a word that sometimes we use that means like part of it, but not all. Semi-perimeter, yeah. So S stands for the semi-perimeter, which is just a fancy way of saying half the perimeter. So this is a lot easier to use than law of cosines. It's not necessary. You can do it without this formula, but it does make it easier. So let's find the area of the triangle. Okay, I'm going to go back to the one we did, just because I can find the area very quickly, because I already know the angle. And let's compare it to when we do this new formula. I do need to know what sides the gamma is between. Think about if you draw it out. Gamma is between which two sides? Yeah? It's between A and B. So let's do 1/2 9 times 7 times sine 33. So 1/2 times 9 times 7 times sine of 33. 33.557. Okay, so 17.412. Keep that number in mind. Okay, 17.412. Let's find the area using Heron's formula, not using this angle at all, and see if we get the same thing. Okay, so what's my semi-perimeter going to be? Ethan? 10.5. These add up to 21. And it doesn't matter if you know which one is A, B, and C, because you have to do S minus every side. If they're labeled A, B, C, that's fine too. So area, square root, S. S minus A, S minus B, S minus C. Okay. What's 10.5 minus 9? 1.5. What's 10.5 minus 7? 3.5. And 10.5 minus 5? 5.5. Let's type that in and see if we get 17.412. Rough. Square root of 10.5, 1.5, 3.5, and 5.5. And we get 17.412. Same answer you get if we use the other formula. But a lot faster because you can avoid law of cosines. Any questions on that? So that's 8.2. Okay, so those are the problems tonight from 8.2. That finishes up everything we're going to be doing with solving triangles. So tomorrow we're going to look at 8.3 and 8.4. 8.3 Wednesday, 8.4 on Thursday. And then we'll have our test on Monday.